When we talk about events, remember we have different types of events which we have already discussed, correct? So when I say we already discussed, you had the same concept last year, right? So we have mutually exclusive events, we have exhaustive events, we have independent, dependent. So there are so many types of events. Now, this particular concept or this particular topic, what we are going to understand is they are called as independent events. Okay, independent events. The name is going to tell you what we are going to study. Independent event. So, independent event, what are those independent events? Now, if one event is not going to affect the second event, they are called as independent events. Very easy to understand, very, very simple, right? So, if there are three events A, B, C, if A is not affecting B and that is not affecting C, then we call those three events as independent events. Now, whenever we talk about independent events, mathematically how we are going to do it. Okay, this is the second part. Now let's look into the conditional probability part. Okay, for that, let's take an example and let's do it. Fair enough? So what we'll do, we'll take an example of, let's say a dice, an unbiased dice. All right. So in an unbiased dice, let's say there are two events. Let's take two events A and B. Now event A is when you roll a die, or let's say we'll take two dice. Let's make things a little more easier. Let's say you take two dice and say when you roll the dice, the sum of the numbers what you get has to be an odd number. Okay. Let's say here we are going to take A is an event where the sum of two dice is odd. Okay. And same thing B is second time you're rolling the die. Like first time you roll the die, the sum has to be odd. And event B is again you are going to roll the die. And when you roll the die second time, the sum has to be odd. That is, sum is odd second time. Second time the sum has to be odd. Alright, so let's try to calculate the probability and everything. So first what we'll do, we'll take the condition of P of A given B, which is P of A intersection B divided by P of B. Correct? This is what we are looking at. Now, P of A intersection B, that is P of, so the first one is sum of the two dice to be odd, sum of the dice in the second roll, that also has to be an odd number. Right? What is the probability of sum being an odd number? Let's look at that way. Okay. See, when you look at it, so there are how many cases? There are a total of 36 cases, correct? We are looking at 1, 1, 1, 2, so on and so forth till 1, 6, right? And then 2, 1, 2, 2, so on and so forth till 6, 2, 6. Then we have the same till 6, 1, 6, 2, so on and so forth till 6, 6. So we have a total of 36 possibility. In this, every alternate we have odd and even, correct? Like the first one is even, next one is odd, next one is even, next one is odd. So till here. That means in one row, we have 3 even, 3 odd. And how many such rows are there? We have 6 such rows. So total of there are 18 odd numbers, like the sum is an odd number, right? There are 18 odd, 18 even, isn't it? So the number of odd is 18. So we can say that P of A is nothing but 18 by 36, correct? Which is half. Now P of A given B, P of A intersection B divided by P of B. P of B is also nothing but 1 by 2 itself, which is 18 by 36. Because sum is an odd number in the second time. That is also 18 by 36. Correct? Now, the second part, that is P of A given B, if we are trying to calculate. So, P of A given B is going to become 9 out of 36. Okay, the 9 out of 36, how we got 9 out of 36? We look into that. See, first one is what? P of A intersection B, correct? Or we can also say this as N of A intersection B by N of B, correct? That's also the same thing. Now, P of A intersection B, when you try to calculate, sum of the two numbers die the first time and in the second time, isn't it? So, in total, there are 9 such values where it's going to be odd in the first one and in the second, correct? So, what we are going to have is that P of A intersection B. Let's write it here itself. P of A intersection B, 9 out of 36. So, what we have now is that P of A intersection B is 9 out of 36. That's 1 by 4. And P of A, P of B is half and half, correct? So, P of A given B becomes 1 divided by 4 divided by 1 by 2, which is nothing but 1 by 2, isn't it? So, P of A given B, if the two events are independent of each other, then probability of B should not affect the probability of A, correct? Or probability of A should not affect the probability of B. Now, this is the proof because this is the same as writing P of A, isn't it? P of A is the same as this one. That means P of A intersection B is nothing but P of B into P of A given B, correct? So P of B was half. P of A given B is also equal to half, which is nothing but P of A intersection B. Just now whatever we calculated. That means P of A given B, this particular term or this particular parameter is the same as writing P of A itself. Because B, this event B is not affecting event A. That's why they're called as independent events, isn't it? So mathematically, when do we say that two events are independent? They are independent when P of A intersection B is equal to P of A into P of B. This is what we call our mathematical proof for two events to be independent of each other. Because when two events are independent of each other, one probability is not affecting the another probability. Make sense? This is the proof, or you can say this is more like a theorem for this one. Suppose if you have three events which are independent, okay, say you have P of A intersection B intersection C. All right, then we can write this as P of A into P of B into P of C. Three events. So take this as the mathematical proof of events to be independent. Clear? Now a very important point. Independent and mutually exclusive are not the same. Okay? Independent is where one event is not affecting the other. Definitely. Mutually exclusive is where one event stops the other. That is mutually exclusive. If one event is happening, then the other event can never happen. That is mutually exclusive. Understood? But independent is where both the events can happen simultaneously, possible, but they don't affect each other. That is independent. Fine? So this is the mathematical proof for events being independent of each other. Fair enough? So in the next video, we'll look into few problems based on the concepts whatever we have learnt.